Hi guys, welcome to revision session number 3 for hire. So same as normal, I'm going to start with the blue ones, then the green ones, then the orange ones. I have to say the orange ones for this paper are quite niche, so I've really not been able to find a question that is similar. So I think if you're wanting to focus on the orange ones, I would say go and watch those Hegarty numbers. So calculating the mean from a histogram, go and watch 418 and 442. And then the ratio problem solving with algebra. As long as your ratio is good, your algebra is good, there isn't very much I can do on those ones, but I'm going to go through the rest up to and including area of a triangle and area of similar shapes. So, okay, question number 1, the number n is rounded to 2 decimal places. The result is 4.76. Using inequalities, write down the error interval. So the error interval is just an inequality showing what the smallest and the biggest the number could have been before we rounded it. So if it's been rounded to 4.76, it's been rounded to the nearest 0.01. It's been rounded to 2 decimal places, so the nearest 0.01. So we half that, and half goes above and half goes below. So your upper bound is going to be 4.765 and your lower bound is going to be 4.755. We then use the letter that they've given us in the middle. Now, it actually can take this value, 4.755. It actually can equal that, because if it equals that, we'll round it up. So that one is an inequality this way. N has to be greater than, or it can equal 4.755. But if it actually equals 4.765, then it would round up to 4.77. So it can go up to, but not including, and that's why we don't put the equal to at this end. It can go to 4.764999 recurring, so infinitely close that we just write that and we just do the inequality symbol to show what it is. So that one was rounded, and that's why we did half above and half below. For the next example, this is an example of truncating. So truncating is when we just chop it off and we don't really care what the next number is. We don't pay any attention to it. So the answer on her calculator display began 8.3. Complete the error interval. So again, you can see we've got the equal to on the left and we haven't got it on the right. They've given us the inequality symbols on this one though. The smallest it could be, okay, so let's just say, for example, that the next number is just coloured in. What is the smallest that could be behind that coloured in bit that I've done? Well, it could be a 0, couldn't it? So the absolute smallest it could be is 8.3. It might just be that. Or it could be 9 recurring, in which case it's basically 8.4. But we just do the less than at that end, to show that it can't actually be that. So with truncating, the method is slightly different, but we're still using the same symbols in the middle for our error interval. Okay, back to one where we're rounding. And if we're rounding to 1 decimal place, then we're rounding to the nearest 0.1. Half of that above is 0.05 and half of that below is 0.05. So we've got 9.85 as our upper bound, 9.75 is our lower bound, X is our letter, and we know it can be greater than or equal to 9.75, but it's got to be smaller than 9.85. Cool. I think we'll skip that one. Samina has a round pencil case and a square pencil case. There are 4 blue pens and 3 red pens in the round pencil case, and there are 3 blue pens and 5 red pens in a square pencil case. She takes at random 1 pen out of each pencil case. So our first pick is from the round pencil case. So out of the round pencil case, there are 4 blue and 3 red pens, making 7 pens in total. So our probability is going to be 4 out of 7 for blue and 3 out of 7 for red. Now for the square pencil case, we've got 3 blue pens and 5 red pens. So the probability is going to be 3 out of 8 and 5 out of 8. And these are independent events. What you pick out of the first pencil case and what you pick out, it doesn't make a difference to what you're picking out of the second pencil case. So we're going to end up with the same probabilities no matter what happens on the first pick. And so it's 3 out of 8, 5 out of 8, 3 out of 8, 5 out of 8. That would be completing the tree diagram. Remember that your branches always have to add up to 1. Now, if we want to know what the probability, I think the question could be something like, what's the probability of getting a blue and then a blue? So what's the probability of getting blue both times? And then another thing we might be asked, what's the probability of getting one of each colour? So let's work out each of these questions. So for the first question, the probability of getting blue and blue again is going to be following this path here. So we want the probability of blue and the probability of blue again. Now we times along the branches and we add the ones we want. So if I want the probability of blue and blue again, it's going to be 4/7 times 3/8. And we know that with timesing fractions, we do the top times the top, numerator times the numerator, and the bottom times the bottom. So that would be 12 out of 56. For the second question that I've made up here, the probability of getting one of each colour. Now, we don't mind if the first one's a blue and the second one's a red, or it could be that the first one's a red and the second one's a blue. Now, either of those options would give us what we wanted, which would be one of each colour. So using the yellow branches here, it would be 4/7 times 5/8. And using the other set of the purple set of branches, we've got 3/7 times 3/8. And we're going to work those out. That was 9/56, and that one is 20/56. And then because we don't mind whether we get blue then red, or if we get red then blue, both of those scenarios we want, so we add those answers together. And hopefully you can see that because the denominators are the same, my answer for that would just be 29 out of 56. So you times along the branches and add the ones you want. Okay, next question. Simplify p to the power of 2, so p squared to the power of 5. Now, a power of a power, we times those powers together. So this is like saying p squared times p squared times p squared times p squared times p squared. So hopefully you can see why that's p to the power of 10. So we times the powers together. For the second question, we're doing 12x7y cubed divided by 6x cubed y. Now, it looks quite daunting. We're just going to take each bit in turn. So first start with your numbers. 12 divided by 6 is 2. X to the power of 7 divided by x cubed. Now, when we divide, we take away the powers. So that's going to be x to the power of 4. And then for the y's, remember a y on its own is the same as y to the power of 1. So if it's y cubed divided by y1, again, we're going to take away those powers and we'd be left with y squared. And that's our final answer. Then we've got m cubed times m to the power of 4. When we times, we add the powers. So this is going to be m to the power of 7. With the second one, we've got 5np cubed, all being cubed. So everything in that bracket needs to be cubed. Now, you could just do 5 cubed, n cubed, and p cubed cubed, and that would be fine to get the answer. It might make more sense to you to write out this times this times this. So we're timesing it by itself 3 times. We're cubing it. So then it's easier to see that 5 times 5 times 5 is 125. So we're cubing that 5. N times n is n cubed, and p cubed times p cubed times p cubed is p to the power of 9. So if we'd have done a power of a power, we could have times them, that would have worked. N would have been cubed, and 5 cubed was 125. So it might make sense for you to write it out. You might prefer not to. It's entirely up to you. For C, again, we're dividing just like we did in the last question. So just look at each part in turn. 32 divided by 4 is 8. Q to the power of 9 divided by q to the power of 3 is q to the power of 6, because we're dividing, so we're taking away the powers. And then r to the power of 4 divided by r is r cubed, because remembering that an r on its own is the same as having r to the power of 1. When we divide, we take away the powers. There are 10 boys and 20 girls in a class. The class has a test. The mean mark for the girls, for all the class, is 60, and the mean mark for the girls is 54. Now, when they give you the mean, there's only one thing we know how to do. The mean is when you add up all the numbers and divide by how many there are. So if they've already done that, then all we can do is times it by how many there are. That's all you can do, because the mean, the only topic that can come up for the mean, add them all up and divide by how many there are. So if they've already done it, we're going to go backwards. So for this question, there are 10 boys and 20 girls. So in the whole class, there are 30 students. Now, the mean mark for the whole class is 60. So if I do 60 times 30 students, I find out that all of the scores for all of the students added up to 1,800. Now, for the girls, they scored 54 and there were 20 of them. So if I do 54 times 20, I'll find out what all the girls' scores added up to. So that would be 1,080. So this is what all of the scores added up to for the boys and the girls. And this is what the girls' scores added up to. So the difference must have been what the boys got. So the boys must have got 720 to make these two add together to make 1,800. How many boys were there? Well, there were 10 boys. So the mean is going to be 720 divided by 10, which is 72 each for the boys. And that would add up to give us the total that we need. So if they ever give you the mean, you want to times it by how many there are to get the total. And then you can go from there and work from there. You couldn't try and work out, because there are a different number of boys and girls, you can't just average it and do it like that. You need to get the totals. You need to work it out properly. So inequalities next. Now, again, very limited questions on inequalities. However, what I need you to do is just remember that with an inequality, we don't treat it any differently to an equation. And all of you should be able to solve a linear equation. And by that, I mean there's no powers. So if there are no powers, we're just trying to get all of the letters on one side and all of the constant terms, the things without a number on the other. And we're treating it exactly as we would an equation. So with this, I've got 14n is greater than 11n add 6. So I'm going to subtract 11n from both sides. So 3n, or let's do it in black, 3n is greater than 6. And we're just going to carry that inequality symbol down. And now we would need to divide this by 3. If it didn't divide, if it was a number that didn't actually go in, you can just write it as a fraction. So n is greater than, for example, 6 over 3. That would be okay. But obviously this does go in, so we're just going to do it. 6 divided by 3 is 2. So my answer on the answer line, really important, has to be n is greater than 2. If I just put 2 on the answer line, that doesn't actually answer the question. Does n need to be bigger than 2, smaller than 2? So we have to put it as it is and just bring this symbol, whatever it is, down, and it stays with the answer. Cool. Shape A can be transformed. Now there are 4 transformations. You've got translation, which is when it's moved, rotation, which is when it's turned, reflection, which is the mirror image, and enlargement. Now you should stop letting me write. And enlargement. You should never, ever, ever be writing moved, turned, mirrored, or made bigger, or grown, or smaller, whatever. These are your key maths vocabulary, and if they're ever asking you to describe what's happened, these are the words that we should be using. I'm just going to restart it, so it lets me write on it. It says that it's been transformed to shape B. Shape A has been transformed to shape B by reflection in the x-axis, followed by a translation. So first thing we need to do is reflect A. So if it's reflecting in the x-axis, that's this line here. And it is 2 squares away from the x-axis, so it's going to be 2 squares away on the other side. So coming down by 2, we can see that our new shape is going to be here. Oh, and imagine I've drawn that slightly better than I have. So there we go. So far it's to there. That's the reflection. And then it needs to be translated by a vector. And they're asking us what the vector is. Now, remember that in a vector, the top number is left and right. Left is negative, right is positive. And the bottom number is up and down. And again, up is positive and down is negative. We need the shape to go, and I like to pick a corner. 1, 2, 3, 4, 5, 6 to the left, and then 1 down to get to the same corner on the other shape. So the vector that we need is -6, because we want to go left, not right. And then to go down, it's going to be -1. So C, the top number in the vector, would be -6, and D, the bottom number in the vector, would be -1. Express 0.418 as a fraction, you must show all your working. Now, to start this question, any recurring decimal, you say let x equal, and we're going to write this out. So 0.418181818. The dots show the start and the end of the repeat. Now, if there are two numbers repeating, I think different teachers will do this in different ways. I personally like to do it the way where if there are two digits repeating, we're going to move it over twice. So to do that, we need to multiply by 100. So 100x is 41.81818118. Now, some of you will do 10x, 1000x, and be able to subtract those two from each other. So if you've learned that way, fine, that's absolutely fine. This is just the way I like to do it. So with 100x being this and x being this, I'm then going to subtract them, because subtracting is going to remove any numbers that are recurring and going on forever and ever and ever. So you can see that if we do the bottom one, take away the top one, that's going to cancel. All of this is going to cancel, and we're left with 41.8 take away 0.4, which is 41.4 on the right hand side. And if we've done 100x take away x, we've got 99x on the left. Dividing through, x is 41.4 over 99, but of course we can't leave it like that with a decimal in it. So I'm going to times the top by 10 and times the bottom by 10. And that would be my answer. They are both even, so it might cancel down from there, but it's not asked me to cancel it. So to be honest, I'm just going to leave that as my answer. And that was a non-calculator question. So you could do it if you want. So we could go to 207 over 495. Yep. And then is that they're both in the 3 times table? Yeah, they're both in the 3 times table. So you could keep going. I mean, yeah, I'm not going to, but you can. Okay, on the grid, shade the region that satisfies all these inequalities. So first thing you need to do, I don't know if you can see them, we need y is greater than 1, x add y is less than 5, sorry, and y is greater than 2x. First thing we're going to do is draw the lines where they're equal. So we want to draw the line y equals 1, and we want to draw the line x add y equals 5, and we want to draw the line y equals 2x. So y equals 1, we should know that that goes through 1 on the y-axis. So that looks like this. That's the line y equals 1. And then we've got x add y is less than 5. So we're drawing x add y equals 5. Think about coordinates that add together to make 5. If you want the line x add y equals 5, then we want the coordinates 0, 5 and 1, 4 and 2, 3 and 3, 2. All of those coordinates add together to make 5. So if I was to plot all of those coordinates, they look like this. And you could even have 6 minus 1, minus 1, 6, for example. So there we go. There's that one. X add y is 5. And then y is greater than 2x. We just need to draw the line y equals 2x. And if you think about y equals mx plus c, we know that this line has a gradient of 2 and a y-intercept of 0. So we're going to go through here. 1 across 2 up, 1 across 2 up, 1 across 2 up. So there we go. That's that one. Again, I should have used straight lines, apologies. I've done a terrible job of doing it on the screen. There we go. So we've got to shade the region that satisfies all these inequalities. Now, if I was guessing, I'm going to guess it's that triangle in the middle, but we're not going to guess, we're going to do it properly. So what you need to do is pick a coordinate on one side of each line and just check if it satisfies the inequality or not. So we need y to be greater than 1. Now, that one's quite obvious. This is the line y equals 1. So if we want everything greater than 1, then we want it to be above the line. And so everything underneath is no good to us. I always shade what I don't want. I just think it's easier to see. So that's fine. Above the green line is where we want. Now, if I'm looking at the blue line, I'm going to use the origin. I find it really easy to use the origin. So is the origin on the right side of the blue line? Let's see. Is 0 add 0? Because the origin has coordinate 0, 0, where x is 0 and y is 0. Is the coordinate 0 add 0 less than 5? Well, yeah, it is. So everything on this side of the blue line is good, and everything above the blue line is no good. And if you picked any of those coordinates, the x and the y coordinate would not be less than 5. So we know that is no good. And then we want y to be greater than 2x. So we're looking at the purple line. I'm going to pick this coordinate here. So I'm just randomly going to pick this point, and that is the coordinate 0, 4. X is 0, y is 4. Let's sub that in. Is 4 greater than 2 lots of 0? Yes, it is. So 4 is greater than 0, so that point is good. So we definitely want, see, look. We were wrong to assume it was the triangle because we want that side. Let's just double check another point. So let's try the coordinate 2, 2, 2, for example. Is 2 greater than 2 lots of 2? No, it isn't. 2 greater than 4? No good. So the purple line, we don't want any of this. That surprised me. Anyway, there we go. It's proved a point, isn't it? Don't assume. So the region that we want is actually that one up there. Never assume it's the triangle. Mostly it is. Never assume. Okay, question number 5. Work out the value of x. So this is a right-angled triangle, and angles are involved. So this is going to tell me that this is a SOHCAHTOA question. So let's put my SOHCAHTOA triangles, and then we're going to label the sides. So 18 is my hypotenuse. X is my opposite because it's opposite the angle that we're interested in. And the adjacent is between the angle that we're looking at and the right angle. We want to work out the value of x. So we definitely want the opposite to be part of our SOHCAHTOA triangles. And we've got the hypotenuse. That's helpful information. With the adjacent, I don't know it and I don't want to know it. So that's not very helpful to me. O and H tells me we're going to use SOH. So this is the triangle that we're going to use. Now I want the opposite. So if we cover that up and do the sum that's left behind, it's sine 30 times 18. Now you can type that in your calculator because it's a calculator paper that we're doing next. But some of you might know that sine 30 is a half. So a half times 18, you should be getting 9 centimeters on your calculator for that side there. 9, wonderful. Here's a triangular prism. Work out the volume of the prism. So the volume of a prism is the area of the cross section times by how far back it goes. So we need the area of this triangle on the end, and then we can times it by 18. Now to get the area of that triangle, I'm going to need to do base times height divided by 2, but I don't have the base. 8.4 is this side here, so that's no good. How could I get this length here? Well, it's a right angled triangle, so we're going to use Pythagoras. So 8.4 squared minus 7.2 squared. The reason we're taking away is because 8.4 is the hypotenuse, and we want a shorter side. So 8.4 squared minus 7.2 squared, and then we square root our answer. So that is 4.32666. And I like to not round it yet. I'm just going to leave it in my calculator for now. So we can put 4.3266 there, but I'm going to round it after. So base times height divided by 2. So I'm going to use that answer I've just got, times it by 7.2, and divide it by 2. So 7.2 times 4.3266 ... divided by 2 equals 15.575985151. That's the area of the triangle. And then we need to times that by how far back it goes. So times that by 18. Times by 18 is 280.367 centimeters cubed. And because it wants 3 significant figures, 1, 2, 3, remember the 0 counts because we've already started counting numbers, it would be 280 centimeters cubed. That's my answer. Okay, next topic is half AB sine C. So the area of a triangle is half AB sine C, where A and B are your 2 sides. AB, and C is the angle in between. So half, side, side, sine, angle in the middle. Okay, so for this triangle here, it wants the length of AB. Oh, this is a very long question. I'm going to change the question because this involves cosine and we don't need cosine for the exam. So find the length of BC. So let's say we're just trying to work out this length here. Okay, let's pretend it said that all along. Working out the length of this side here. So I'm just going to put an X there so I know what I am working out. And then I'm going to write what I know. So I know the area of the triangle is 42. So half times A times B, X, sine 70 equals 42. So half AB sine angle equals, and they've told us the answer is 42. Okay, so we then just need to work out the missing value. I can do half times 7 times sine 70. So I'm going to go ahead and do that bit. 0.5 times 0.5 times 7 times sine 70 is, it's not letting me write anymore, so I might have to vocally do this one. So I've done half times 7 times sine 70, which is 3.2889, and I'm then going to do 42 divided by that to get my answer, which is 12.770. So that's going to be the missing side. So remember, if you want the area of a triangle, you can just do half AB sine C. So you're timesing those things together. Oh, that's it. Okay, so with the here, if there's anything I haven't covered, which, to be honest, it's the calculating a mean from a histogram and ratio problem solving with algebra. Do those Hecate numbers. So 418, 442, 285, 329, and 323. If you're really looking for that grade 9, I would just recommend that you do those ones for the exam. I hope that was helpful. Yeah, enjoy. Good luck.